Hello. Ooh. Hi. Thank you so much for that amazing introduction. So hey, everyone. My name is Shirley, and this is
Nadieh.
And we're two data visualization freelancers from Amsterdam and San Francisco. And for the last 10 months, we've been working on a project called Data Sketches, where we take a topic each month and visualize it by around the end of the month. So let's start from the very beginning. Nadieh and I actually met online in a private data visualization Slack in the fall of 2015 and didn't actually meet each other in person until CSSconf in Boston last year, where we had the pleasure of giving talks separately and hang out for 3 whole days where we got along really well, so that when 2 months later Nadieh put up her SVG tutorials that accompanied her talks, I dove into them with vigor. And as I started talking to Nadieh with questions about her tutorials, we started somehow commiserating around the fact that we really hadn't completed as many data visualization side projects as we were hoping for in the past year. And that was when I had an idea. And I asked Nadieh, fully expecting to be rejected, "Do you want to collaborate with me?" And then she said yes, yay! And that's how Data Sketches started.
So in the following week, we figured out that we both liked the idea where we would create a visualization around a specific topic each month and do that for a year, to see how 2 people would create 2 visualizations, starting from the same seed, the topic, and then diverging into different paths based on our own interests and history. But besides sharing the end result, we also wanted to write about the creation process. And we split this up into the 3 pillars that we find most important: data, sketches, and coding. And initially, we thought we could pull data sketches off with about 5 to 6 hours a week. But yeah, as usual, real life doesn't really care about your plans, especially coding plans. So since starting in July 2016, we've clocked many, many hours into creating a visualization each month. And during this talk, we'd like to take you through some of the lessons that we learned, the challenges that we faced and how we tackled them, and the insights that we gathered along the way.
So let's start with the data. We often get asked this question: do you get your data first and then come up with the idea, or do you get your ideas first? And for the 2 of us, the answer is always, always idea first. So for example, for our November data sketches, I visualized every single line in the musical called Hamilton, and built a tool where I can filter by any set of characters, their conversations, and phrases, and then be able to dig into all of the lyrics that were left in the remaining songs. And the question I started with was this: how do the relationships change between the characters as the musical progresses? And what are the recurring phrases, and who are they associated with? Now, as you can probably imagine, this data was not available online anywhere. So I had to go through each of those lyrics, noting every single time a phrase occurred across more than one song, group those phrases into themes, and then go through the lyrics again, entering them into the computer and associating them with the right song and line number, and doing the exact same thing for the characters and conversations. And then I wrote a script to aggregate those characters and themes by their song and line number to get my final data set. In a more extreme example, for October, decided that I wanted to put emojis on Mr. and Mrs. Obama's faces. So I have here every YouTube video that you can dig through of their late-night talk show appearances. And here you can go through each of the scenes, click on any of the frames, and see their faces on... Oh, the images are not loading. But if they load it, then you can see the faces. Oh, no. Oh, there we go. Yeah, so emojis on their faces. Thank you. This still brings me joy. I did this for the election because it was bumming me out, and then this still brings me joy. So the idea really started with when I was talking to one of our friends, Eric, and he said, wouldn't it be cool if you could run facial detection on the videos and correlate their emotions with what they're saying? And I was like, hey, Eric, you realize I only have 1 month to do this. And then I was like, you know what? Hey, Eric, challenge accepted. So to do this, I had to manually first gather all of the late-night talk show appearances off of IMDb, get their corresponding YouTube videos off of their hosts' channels, use a Node package to download all the videos and their captions so that I can get the timestamps from those captions, to take a screenshot every time somebody talked, and upload them to the Google Vision API, which is this really fun API that gives me the bounds of their faces, as well as data about whether or not each of these people were happy or angry or sad or was wearing a hat. And gave that data back to me in a JSON format that then I could write a script to aggregate with the caption data to get my final data set. Woo! And so what these two kind of extreme examples taught me was that if I have a curiosity, any curiosity, that I can get the data, it's out there somehow, whether I have to go manually gather them or write a bunch of automated scripts, which, by the way, I found that there's a Node library for anything I can imagine under the sun, as long as I play responsibly and legally.
So thankfully, not every month is as data intensive, as Shirley just showed us. There are more normal months and places you can find data online. For example, for August, I decided to dive into the Olympics. Well, our theme was the Olympics because it was rather obvious, and we are both big fans. And I wanted to visualize all 5,000 gold medal winners since the very first Olympic Games in 1896. So each of these circles is a group of similar sports, like water sports or ball sports. And then each of these slices or feathers within a circle is one sport, like athletics. And then we have the first version going outward to 2016. The reddish background are female events, the bluish background are male events. And then finally, the color of each of these medals is the continent in which the country lies that won the medal. So for example, Europe is blue, and Americas is red, and so on. And we can see that at the very first editions, there were no female athletics events, but we've been catching up since then, thankfully. And I found the data set for this piece from 2 articles published by The Guardian for the 2012 Games in London. However, after getting a rough shape of my visual on the screen, I noticed some very obvious medals were missing from 2012, like hockey. So suddenly, my confidence in this data set dropped drastically, and I had to get a sense of the actual accuracy of this data set. But I didn't want to have to manually go through all 5,000 medals myself, manually, although I'm still wondering if Shirley would have.
Would not have.
So I found a proxy instead. And on Wikipedia, I could find a number of events that occurred for each of the editions, and I could compare that to the number of gold medals I had in my data set. And if there was a discrepancy, I dug deeper to figure out where and why. And that's how I found out that for some of the years, the horses were also in the dataset winning gold, which makes for an interesting read to suddenly see Princess and Sissy and Lady Mirka as women winning gold in the Olympics. Well, finally, I figured out each discrepancy and made adjustments to my data to get it to the point where I trusted it again. And my lesson here was that even coming from such a respectable source as The Guardian, I really need to get a sense of accuracy and completeness of my data, because missing data can be harder to find than wrong data. You don't always have to check every value, but think about taking sums and counts and averages and comparing these to plain common sense, or even better, a different data source. So many people jump straight from data to final visual, but take some time and sit back and sketch out your ideas instead. We've filled many pages of our notebooks since starting because sketching helps us think and lay out ideas beforehand. And my sketches are often very simple. And I really only focus on the main abstract shape that I want to fit my data into, like colors and layout and details. These are things I only vaguely think about, but don't act on until I have the data on my screen. There's just no use to think about these things until I figured out that the data works once I've morphed it into the final shape. And for the Olympics, for example, I had this idea of feathers, placing more emphasis on the recent additions. However, I had no idea if that would look all right when I finally placed all 5,000 medals together. I had to see if the general shape would work before moving on. So I started laying out the feathers, and it took a few steps, but eventually I came to the point where I saw that luckily it did show potential with the actual data. But sometimes there is no use to start sketching on paper, although I will say that's very rare. But networks are an exception for me. And for October, my thing to dive into was royalty versus the Obamas. And I've always been intrigued by how intermarried the royals really are. You know, are they all cousins twice removed? And luckily, I found a genealogy data set that contained a gigantic family tree of the European royal houses. It was from 1992, so I had to add 1 or 2 more generations in the main line of succession, which was a fun night on Wikipedia. But so here we have the family tree of 3,000 people. And the current royal leaders are the big circles, and everybody is connected to their parents, their partner, and their children. And to highlight the interconnections, you can actually hover over anybody and see how far their 6 degrees of separation would lead into the web. You can also click on anybody, let's see if that works here, and anybody else, to see the shortest path between these 2 people, because the entire web is connected. Well, but when I started out with this data set, I had no idea what it contained. So I just put everybody on the page using the most basic network settings, and this happened. An explosion of points and lines going out of my screen. Well, let's rein in gravity a bit then, but that left me with a useless hairball. Well, maybe I could color them by year of birth. No, not helping. But luckily in D3's version, well, the newest version, you can have gravity depend on variables. So I pulled the web apart by year of birth as well. That was better, but it was still a rather uninsightful bundle. And at this point, I'd already invested several hours into playing with the network settings, playing with the different kinds of connection, adjusting my data, and I was really ready to just give up. But, you know, I gave it one last try. And this time, I decided to focus on the current royal leaders. So I placed these in a line, and then I let the vertical gravity depend on how, you know, which of these current royal leaders you were most closely related to. And that's when I finally saw it. Insights. For example, that the Queen of Denmark over here is actually very central to the web, whereas the Prince of Monaco line here is separated from the rest more than 200 years ago. And it was only around this time that I finally started thinking about more of the design aspects. And networks often remind me of constellations, and with my astronomy background, I have a bias for all things space, so I turned it into a starry night. And the thing is, I could have never designed this visualization beforehand. I had to go hand in hand with the actual data and apply my design choices to all of the data simultaneously to see if the results were both engaging and insightful.
So Nadieh gave us a really great example of when we land on the right visualization form early on in our process. But that's not always the case. So for our March data sketches, we had the incredible opportunity to work with the Google News Lab and their search data dating back to 2004. And with access to this incredible amount of data, I wanted to take a look at what countries search for around the world for travel across each different seasons and for a particular country. I wanted to be able to see for each of those topics, what are the search interests across the years and their seasonality patterns. But to get to this point, I first asked, what are the top search countries? And it turns out it's Brazil. And then I wondered, who's searching for Brazil? What are the kind of topics that are being searched for Brazil and each of those countries? And what are the distributions like across each of the years? And then I wondered, can I put search interests in there somehow? Which did not turn out so well. I call this my plunger series. So I took a step back, and I said, OK, so maybe I can try out circles as each of those topics and show the search interest as the radius of each circle. And for each country searching for that topic, I'll have overlapping circles. And this is what it looked like. And I thought it looked pretty OK. It's kind of pretty. So then I wondered, well, I think I noticed that maybe geography plays a part in who's searching for a country and topics within the country. So maybe I can try sorting those topics for a particular year by distance. And that didn't look so great. So then I was like, maybe I can just concentrate on one topic across the years. And that looks like maybe it will lend nicely to a heat map. And I was like, this is not going anywhere. And then, but then I remembered that earlier on in my explorations, I had noticed that there's a lot of seasonality in a lot of the topics. So then when I wondered, can I filter and group each of those topics by each of the seasons? And maybe, this sounded kind of promising, like maybe I'll be able to get some insights out of this. And nope. It turns out that each of those topics are searched for across all of the seasons, which meant that each of the graphs actually looked exactly the same. I was really disappointed. But then I remembered that, hey, the search interests are different across each of the seasons, which means that if I just size the height of each of those blocks by the search interest, then I can start getting insights like this one, that the United States searches for travel more often in the spring than in the fall. So finally, ta-da, the final visualization, where each of the blocks represent a topic grouped by their country, and I can toggle between the seasons and see insights like, for example, that Mexico's search interest is low in the summer, but the Canada is high, and the same is true for the hotter countries around the world, like the Thailand and the Philippines, but when I toggle to winter, the opposite is true, and I can see that Mexico peaks where Canada drops, and Thailand and the Philippines have peaked also. So the lesson I learned is that sometimes we don't get the right visualization for the data on our first or second or even third sketch. So be patient and go back and forth with the sketch and code to figure out what works and, more importantly, what doesn't work, so we can figure out where to go next.
So as expected, most of our hours are spent on actually getting the data on the screen. And here are some of our maybe less obvious coding lessons. For our very first month, the topic was movies. And for me, it was immediately clear I wanted to do something with The Lord of the Rings. And I found this amazing data set that contained the number of words spoken by each character in each scene of all 3 extended editions of The Lord of the Rings. I mean, how amazing is that? I mean, I knew I had to visualize that. And I decided to focus on the fellowship members. So how much had each member of the fellowship spoken at the different locations that we have outside here? Well, no surprise maybe that Gandalf says the most, but my favorite insight was that Boromir, who is really only alive during 1 movie, manages to speak more than Legolas does in 3. I didn't know that. Anyway, here is a sketch of my project, and when I saw it, I found that it was very similar looking to a chord diagram. So I decided to start from there and then slowly transform the chord diagram into my sketch. And here we have a typical chord diagram. And the most fundamental thing to me is if I could figure out how to get these inner chords to flow towards the center, which actually took less time than anticipated, which is very rare for me in coding. But getting rid of the space, and now it was ready to handle the actual Lord of the Rings data in some more appropriate colors. Well, we have 9 members of the fellowship, so I had to make sure the centers end up at the right vertical location, but now it's getting very squished. So I just pulled the 2 halves apart. But these chords, they're looking kind of unnatural right now. And that's when I decided to finally dive into SVG paths and learn how to make them myself. It took a while, but it was really an improvement on these chords, how they looked finally. And that's how I sort of ended up with this new kind of chart that mutated from the chord diagram. And many people have done wonderful work that you can use. So even if you are creating something new, you don't always have to start from scratch. Just pick the thing that lies most closely to your design or idea and start adjusting that. You know, remix what's out there already.
But sometimes we manage to dream up things that are unique enough where there's no base for us to remix off of. For that same month of movies, I wanted to look at the top summer blockbusters of the past 2 decades and reimagine them as flowers. So each of the colors represent a different genre, and the size and the number of petals of the flowers correspond to their IMDb ratings. And so we have some really beautiful ones in here, like The Dark Knight Rises, and Inception, and Slumdog Millionaire. But my absolute favorite is the 1997 Batman and Robin, because it's so teeny tiny and so cute. I think it's so cute. And I've gotten really great responses for this. And people have asked me, how did you make this visualization? How long did it take you? And the answer is actually that it's actually really simple and straightforward. And all it takes is a good grasp of the SVG paths, and in particular, the cubic Bezier curve command. And so how that works is we start with a point, in this case 0, 0. And the way that I like to think about it is that we draw a line from that starting point to the ending purple point. And then we take the blue and green anchor points and nudge them out until we get the curve that we want. We draw a line, 2 lines, or I draw 2 lines, and then make the same curve on the other side, rotate the petals out, and then add in the colors. And that was it. So really understand the tools that you're using, because with that understanding, we can really go beyond the prescribed examples, the pre-existing examples that are out there already. And in particular, out of all of the tools that we use, SVG paths is probably our favorite, because with a good grasp of SVG paths, we can make any shape that we dream up for truly unique results.
So besides SVG paths, we've also had a lot of fun playing with math in the past few months. And as my addition to the collaboration month with Google News Lab, I decided to dive into translations. So what have other languages translated to English? Going from the most translated words for 10 chosen languages, like German and Dutch and more, to the top 10 most translated words, down to the similarities between languages. And here, each of the lines between 2 languages represents 1 word that these 2 languages have in common between their top 10. And at first, I wanted to replace all of these lines with the actual words that they represent. Well, yeah, then I actually saw it, and it's a complete mess. It's way too busy. So it took a few iterations to finally get to this more focused and clear version. But one of the most important things here was that these words over here were all as upright as possible for readability. But that turned into some convoluted calculations to get these text paths, which became glaringly obvious once I click one of these circles, which moves it to the center. Yeah, that wasn't quite how you might have expected it to go. So I needed to figure out how to fix that. And that's where math and rational problem solving came to the rescue. Yeah, it took a few pages out of my notebook, but eventually I figured out how to implement the solution. So now if I click any of these languages, it is more like somebody would expect it to go. But what I've done is really more of a hack maybe, because once you click one of these circles, the words, they are faded out, and then I immediately replace all of these lines with their final states, but I've reverse engineered them to their previous state and then smoothly transitioned them to the final states. So my lesson here was, I guess I knew it already, but if you are doing something new, definitely expect that it will take time, because you are going to encounter struggles. And if you didn't already, learn to love math, because it is usually your best friend in solving these kinds of visual problems.
So thus far, we've talked about what I like to call the first 80%, the data preparation, the ideation, the sketching, and the visualization itself. But there's the rest of the 20%, the details that we find really important also. So when I started thinking about the story for Hamilton, I knew that I wanted it to reach a wider audience than usual, and I knew that I wanted them to be engaged enough to keep scrolling down the screen. So the very first thing I did was on page load, all of the dots fly into the center to create the Hamilton logo. And as the user starts scrolling down the screen, the dots fly apart and then dance around until they get pulled back in together so that I can show the reader that, hey, each of these dots are actually song lyrics. And as the reader scrolls into the first section of analysis, each of these sections are actually corresponding with one of the songs. So then I highlight the right corresponding song for them. Another thing that I did is that if the user decides they want to click on one of the songs, oh, there's no...
maybe this?
No audio? OK, well, believe me when I say that there's a song playing somewhere in there. So as you can see, there's a progress bar that I highlight in the visualization in the right so that the user can get a sense of where the song is that's playing relative to the rest of the musical. Another example, a smaller example that I want to show you is that for that same month of travel, I have these sections where I animate how to read different sections of the visualizations. But I don't start the animations until the user scrolls down into the correct section so that no matter how quickly or slowly they scroll, they can always see the animation from start to beginning. And it's really these small attentions to detail and attempts at delight that really make a piece for me because it tells the reader that we really care about their experience.
And even more examples of things you could do with delight. Well, on a flight back to Amsterdam, actually from CSSconf in Melbourne, I decided to make, I hope if it ever gets to the next page.
We might have to.
Oh no. There we go.
There we go.
Right. So I didn't have any Wi-Fi, at 10,000 feet, so I couldn't do anything essential. And I decided to just create an animated legend of my visualization about fantasy books, for fun. Or adding animated GIFs of the most memorable and fun moments in Dragon Ball Z. Or having a hover with the most detailed information I had for music nerds in my December music visual. Or turning the top 10 songs into tiny vinyls. Having annotations about weird and silly events of the Olympic Games. Like Henry Pierce having to stop for ducks in the rowing event, but still managing to win gold. Although getting your data on the screen in such a manner as to make it insightful is key, it's the extra things to add, like animations, annotations, weird legends, GIFs, and more that will make it unique and special and even more of a delight to investigate. So take some time to think about these aspects as well.
So finally, we get to the soft stuff, or what I like to call the best stuff. So when Nadieh and I started talking about this project, we really weren't expecting the kind of response we got. We thought that if we could just have fun and maybe learn some things, and if our friends enjoyed it, then that'd be enough, then that'd be really cool. But instead, we've gotten the most amazing feedback both about our visualizations and the value of our write-ups. And we've had the opportunities to meet some amazing, incredible people and talk to them. And even gain an unexpectedly great friendship out of all of this. But when we really sat back to think about the transferable lessons, the most important thing that we agreed on is that if you're about to embark on an ambitious project, grab someone to go along the ride with you, because then you can motivate and support each other when things get tough. And make sure that that someone you grab is, if you're not so responsible yourself, that it's someone very responsible so that you can keep each other accountable and relatively on track because you don't want to let each other down. Make sure that someone you grab is someone you really respect, and hopefully the feeling is mutual. You respect each other. But most importantly, that someone is someone you trust or can grow to trust. because that's absolutely essential to giving and receiving feedback. And finally, if you're about to do something ambitious, like make a data visualization from scratch every single month, know that it's going to be hard. We've been creatively drained. There have been months where we've been creatively drained and we didn't know how to go on. Just remember, you learn as you struggle. And the amount that we've learned, both personally and technically, have been absolutely amazing and very much worth the time.
So over the last 10 months, we've learned to find data in the weirdest of places, that you can sketch to weed out thinking errors, but that you can also sketch with code. That SVG paths and math are amazing, but we really already knew that, of course. And that surprisingly small things can add a sense of delight to your audience. And we didn't set out to learn or be confronted by all of these things. Like Shirley said, we set out to have fun, and in that we definitely succeeded. Sure, it's been tough. There were times when we were coding into the night when we would have rather binged the TV show, but it had opened up new paths and opportunities that we weren't even looking for. So we hope that you'll join us in our final 2 months of data munging, sketching, and coding up our topics into fun, weird, and overtly elaborate visualizations. Thank you very much for your attention.
Whoa, how was that? datasketch.es